Okay, there are my slides. It's good to be back here at FITC. Thank you. So I'm from Toronto. I lived here for over 15 years. Right now I'm in the States, working for Google with the Angular team. Stuff that I do on the framework is mostly animation and layout effects and core stuff, a part of the framework. And I've been doing so. The description is a bit outdated. It's been about 4 years now, almost. So here we have the link to the slides, and we have some demos that go along with the slides. There's a handful of demos that showcase the animation capabilities of Angular2, as well as some of the basic component mechanisms and some of the layout effects, which I'll talk about today. As you guys are copying that down, I'll just explain how I got involved with this project. 4 years ago, I was blogging about Angular, and back then it was version 1.0. There wasn't really too much that was out in the open about the framework. So I was blogging about it, and I contacted the owners. I was like, hey guys, I've done so-and-so blogs. I'm really interested in this framework, and I want all these features, but I want to blog about these features, but these features don't exist. And their reply was, if you want it so bad, why don't you build it, and we'll hire you to build it. I'm like, what, really? And that ultimately led me to working on animations for the framework, which then led me to become a core member. And then I pursued a job at Google and moved to the States, so it worked out. But I'm still involved with the framework, and I really enjoy working with it. And I'm going to talk to you guys today about some UI building blocks and nice ways to build a fancy UI with Angular2. So, the building blocks. When it comes to building an Angular website, Angular2 website, I'm going to talk about these core level things such as components, animations, and layouts, and all the stuff in between. So what first comes to mind when you think about components? Well, you might think that components allow for HTML, CSS to be kind of encapsulated into one tag. If anyone's used Polymer before, they make great use of web components. And Angular also has its own component system in Angular2 as well as Angular1, but it's more emphasized in Angular2. So here, for example, we have a video tag. And for anyone who's used the video tag, you might realize, oh wow, there's a few controls in the video tag that we have, such as the play, the pause, and the scrubbing capabilities. But none of that stuff is actually a part of the HTML code that you put into the video tag. So that means that the video component has its own template behind the scenes where it's populating certain elements of the component. So this is the exact notion of a web component. It's a tag that contains its own template, its own level of HTML code, and it has inputs and outputs that are able to communicate with that template and to update things on screen. So with Angular 2.0, we make heavy use of components, but the framework itself is a full-fledged JavaScript framework that was a complete rewrite from AngularJS, the predecessor. And the reasoning for the rewrite was to allow for more performance and tooling and to make Angular a platform-agnostic framework, which means that you can use the framework for making an iOS app or an Android app, as well as a web application. So what are the features of the new framework? The biggest point is that we have rich language support. It's written with TypeScript and ES6. And the templating language allows us to define inputs and outputs in a convenient and consistent way. The tooling and validation will tell us when our code is failing ahead of time. It allows for very in-depth testing as well. And the whole framework is a nice foundation for building sophisticated UIs. So we briefly go over the basics. I'm sure that there are some beginners in here who would like to see how Angular works. ES6 and TypeScript, we'll talk about that in a second. And I've mentioned the importance of components, and components contain templates as well as bindings and events. So ECMAScript 6, we all know this as the next level of JavaScript support, allowing nice things like classes and modules and promises. All of these features which have been present in other languages such as Java, C#, now are coming to JavaScript. And it's really cool because over time the browsers will start to support this. But for now, we can't do this directly in the browser, and I'll get to that in a second. But one thing that's missing from JavaScript, which has been missing for a long time, is type support. And TypeScript allows you to pass in typing information to better describe the relationship between your programming data and your application. I used to kind of think like, okay, I've been a JavaScript developer for a long time. I don't need types. Like, this is a very dynamic and fluid language. I thought that types were only required for static and very strict languages. But after using TypeScript for 2 years, I've actually come to find that it actually makes developing JavaScript much better. Because if you look at something like this, you have a full understanding of how all the data relates in the class. We know that an ID is a number and a name is a string. If I were to pass a number to the name value, it would throw an error, and vice versa. Having a class here is something that ES6 provides, and annotations are kind of a feature that exists both in ES6 and in TypeScript. This is all extra data, programming data that we can use in our application. But as we well know, this code does not work right off the bat. We have to use a transpiler, and TypeScript is a transpiler, or we can use Babel or Tracer to turn this JavaScript code, the high-level JavaScript code, into something that a browser can understand. Now, I would never maintain code like this because this code right here is a bit too tricky to deal with, but having the high-level JavaScript code gives me a lot, like it makes my code run for a lot longer. I can maintain the code over time, and I know that it will work in modern browsers. All right, so let me just do a quick demo with Angular2. So I have an application, and this is a component. We have an app component. We have the annotation above that's describing what the component is. It has a selector, it has a style sheet, it has an HTML file. Now, if I hop into the HTML file, I have a text that says hello, and let's say I want to have name. So I just want to say hello, name. So in here, in the component, I can add a property called name and say, or let's call it fitc. So now, you can see that it says hello, fitc. That is the JavaScript code communicating with the template to update the binding. If I wanted to have, say, an input field change that value, I could just pass an input field, and we all know that an input field has an input event that occurs when the text is changed, and we could say, when this input event changes, let's set name equal to something changed. So now, I hop in the input field, something has changed. Cool. The web page updates automatically. There's no need to find an element in the DOM and update its value. Angular handles a relationship between the bindings and the input data. So let's say that I actually want to record what was inputted. I can actually pass a reference to this element. I could say input elm. And now I could say input elm dot value. So now, if I update the value, you can see that the binding updates automatically as well. So that shows the relationship with bindings and inputs and outputs. Let's do one last thing. Let's make a component that will take that value that I have for hello and make it into bold. So we'll say bold CMP, and we'll say value is equal to fitc. So that is just a string value for bold CMP. So I'm going to make a new component. I'm going to call it bold CMP. There's no styles. And the template, all that the template's going to be is just, it's going to take a value and it's just going to make it into bold. Not a particularly useful component, but the point is, that we can easily pass data into a component from another component, which I'm going to show right here. So if we say value is equal to empty string, we can actually say input and the value that you passed in from the outer component. So we have an input injected here. So these are called ES6 imports, so you can import code from other files. And now, all I need to do is add the bold component to the Angular module. So I add it right here. This is where the importing comes in handy. Now, if all goes well, you can see that fitc is in bold. Cool. But the value is still not dynamic. What would be cool is if it could actually record the value that I get from the input. And what Angular allows is these things called property bindings, where you can actually pass in a variable. So in this case, we have name. And now, whenever name changes, you can see that it updates the value inside of the component. So this is the whole notion of having multiple components communicating with each other in Angular 2. And this is the first element of building blocks when it comes to building a sophisticated UI. Oops. Okay. Cool. So we just talked about components. And we know that when it comes to components, everything is nicely encapsulated together. All the data that I had, all the bindings and variables belong into the class. And you saw that I was changing data and the UI was updating automatically. So it's nice to think about components as if they were mini programs. When it comes to templates, we saw that we had data from the component that was bound into the template itself, and the browser automatically rendered it when that data changed. The inputs and outputs, those property bindings and the parentheses, which handle bindings and events, are automatically triggered when the data flows between components. So let's say that we had another component, in this case a mapping component, which would show an image of the location that you have. So in this case, we're in Toronto, so I put location equals Toronto. The component in this case, we saw that I had an input of location. That's the data that's passed into the component. And then all that's doing is it's building a Google Maps image string, which I pass into an image to represent where we are. Inside of this component, it contains its own template, which effectively renders out the data when that component is used. So much like the video tag has controls. This mapping component has an image, and we can see with the SRC that we are binding the image URL value as if it were a property of the image. So I'm going to show my first big demo, which is a dossier demo. So a dossier is just a collection of data. And this is a dossier of myself, which contains the friends I have at FITC, a nice collection of components that represent each of my data. So we have the maps, and we have the profile information, and my friends. So these are all components that I'm using in the dossier. You can see that it's very clear and easy to read. We know exactly what data is being passed in. Let's take a look at the demo. So here, there's no animations here. It's just a, oops. Okay, scrolling. Okay. Anyways, okay, my scrolling's not working with this for some reason. That's fine. Here we have some data. Okay. Here we have some data about me, and we have the two maps, and below that we have a collection of friends. And all of this data is just components, and the data is passed from a top-level component into the subcomponents to represent that data. If I look at the code quickly in our first demo, we look at dossier, we look at the demo.html, and in here, all that I'm saying is I'm passing a JSON file, which contains everything I need to run this dossier. And then in the HTML code, much like the slide, we're loading in the profile, we're loading in the two maps, and we're loading in the friends. Each of these things get a piece of data that's collected from the JSON file, and the components work in pure isolation. Okay, continuing. Let's talk about Angular for designers, because this conference has designers, and I've been designing using CSS for a long time. And it's really important that a framework pays attention to this kind of stuff. It's really important that they care about layouts and animations to make a UI very snappy and fun. So Angular is trying to make a better effort at getting more friendly with designers. And by improving the animation story as well as the layout story, we think that we can make the framework more appealing. So let's talk about the animation basics for a second. So this is the stuff that I work on primarily at Google. Animations in Angular 2, much like all the other data, is defined within the component. We have a DSL, which is a language for defining animations that lives within the component, and all of the animations are triggered within state-based changes. So the DSL involves a mixture of CSS and HTML. Well, not exactly. It's actually real JavaScript code that dictates an animation and all the steps that are involved with the animation. The nice thing about this is because we have our own language, we can port all the animation code to an iOS device or an Android device, or have it work in a non-DOM context. And what that means is we have a feature in Angular called AOT, which means ahead of time compile. That means that all the code that you have in your CSS code, in each of the components, all the template files, when you're ready to push your website to production, it will compress everything, put it all together into a nice package, and upload it to the server. The animations will also be compressed and handled, and they will be very fast when the website loads. So if you're thinking AngularJS had a strong emphasis on CSS, but Angular2 has its own animation language. Why did we make the switch? Well, CSS is tricky to detect sometimes because you have to rely on DOM APIs such as getComputedStyle, and you can't parse the style sheet unless it's the same origin. It would be better if we handled that on the framework level. So we're not using CSS in Angular 2. We're using the Web Animations API. And so far, it's supported with Chrome and Firefox. Safari has announced support with their next with the next version of Safari. And Edge will hopefully soon support it as well. So here's what it looks like. For the browsers that support this, I can just pick a DOM element, say animate, pass in some styles, animate it over a certain duration. But web animations in general are a bit strict because we can't detect classes or keyframes or styles from a style sheet. We have to know all the styles that are defined. And if I want to have an animation that changes in the middle of its animation to something else, it's pretty tricky to do so. Once again, it animates only on one element at a time. So what the Angular animation DSL does is it works on top of web animations, but it makes everything a lot more flexible because the framework has a lot of knowledge about CSS and about the layout of the application to make that work. So if you have an example like this, this will turn into this with Angular's animation API. We're saying when the myAnimation trigger is executed and it goes from any state to another state, animate it from being invisible to being visible. But you might be thinking that there's actually more code in this than there is in the previous example. But the point is that even though there is a little bit more code, this is all contained within the component, which makes it very reusable. And we can improve the performance behind the scenes, and we can test it very well as well. So that is a DSL. How are these animations invoked? Well, much like properties that we can see in our HTML template, we can have animation properties as well. So here we have a component that lists all the months of the year. And in that component definition, we have a template which lists each of the months using something called ng4, which is exactly what you think it is. It takes an array of items and it prints them out on the page. But if you notice, we have an @ symbol called month animation. What this means is we're going to run the month animation every time that div is inserted into the page or removed. So here we're saying month animation, enter, make sure it's hidden right away, and then animate it for half a second into the page and expand it, and leave, make sure that it already is on the page, and then remove it when the element is removed from the page. So the animation is nicely a part of the component. Let's take a look at the demo that does this. Oops. Here we have the list of months from January to December. If I were to hide all the months, you can see that they all disappear and animate away. If I enter, they all enter it as well. I can choose even months and odd months. But the animations, for each of these items that's been inserted, we just have an enter and a leave animation, and we're changing its styling within our animation DSL code. So once again, this DSL code facilitates the animation for each of those items that's been inserted into the page, just because it has that @ symbol which refers to the animation trigger. Okay, so let's look at one more component. A common animation that people want to do is having elements expand and collapse, depending on if a component is open or closed. So here we have a Boolean for open, and we have a toggle that flips the Boolean every time it's called. We have a template then that when you click on a button, it will toggle, which will then trigger a property, an animation property called slide open. So when slide open is true, it goes into its open state. And when it's not true, it goes into a closed state. So effectively, we can think of the animation from going open to close. And that's exactly what we can define here. We can have a state for it being open, and we can set its height to be star. And what star means is that it will detect the height as soon as the animation starts. And then closed, it has a height of 0. When the transition occurs from closed to open, we will animate it for ½ second with an easing. So this is the third demo. And once again, all these demos are a part of the GitHub repo. Here we have that box, and we click open and close. And Angular is able to detect the height and animate the state change between open and closed. So if I look, if I look quickly at that demo, we have a slider component, and the slider component, this is a little bit different from the example, but here we are changing the open-closed state, and in here we are changing its height to star and vice versa. Okay. So what about if you want to know if an animation is finished? Well, Angular2 allows you to detect the start and the done events of the animation. So here, for example, we're checking to see when this animation has started and when it's finished, and we can get optional event data, which tells us what state it has jumped from to what state it's going to, and how long the animation runs for. So if our slide demo were to have this event, we can detect when the start happens and when the done happens as well. And here's the fourth demo. There's a lot of demos. Here we have a gallery of images. We click on one image, it loads. We click on another image, it loads. We click on a beautiful image of Toronto, it will load. This effect has a loading animation which occurs, and that loading animation has to animate itself into the page, and once the loading animation is finished, it will then trigger the image change to happen. That's why it's so smooth, and that's why there's no flicker that occurs with the image. This happens with a loading animation and then the loading callback for finished when it's done. If I quickly look at the code here, we have an image preview, which has a loading animation. And then for that loading animation, once it has finished, we will call this method called loading stage ready, and we will replace the image. So those are the nice benefits of having the callbacks in Angular2. Okay, so before I hop into layouts, let's talk quickly about how all this stuff works. Since we have a DSL, which basically means we have our own language, there needs to be a preparation phase where it parses the code and tells you if the code is incorrectly formatted. And then once the animation is run, it needs to run it in the most efficient way possible, and then clean up. After it's done, it needs to destroy all the elements that were involved in the animation. So we have a CSS parser in Angular2. We also have an animation parser. It parses the animation DSL language, and it produces something called an AST, which is an abstract series of instructions or data that we can use to produce machine code. So when I say machine code, I mean efficient JavaScript code, which is then used to run the animation. And this is the compilation phase where it takes that AST and it produces that code. And this is when I came back to saying that it's AOT, ahead of time friendly. All of this code will happen before you upload your website to production. So if you have animation code that looks like this, that contains the open and close states, one run for the compiler, it will produce JavaScript code that looks like this. Now, this is not designed to be read by somebody or maintained by somebody. It runs when the website is pushed to production. And it actually might look like there's more code in here. Well, there definitely is more code in here. But the point of this is that it doesn't need to go through the framework at all. It knows everything that it needs to know in this ball of JavaScript code to run the animation. And as Angular gets more and more advanced over time, we'll actually have more code-generated code that will require less and less of the framework. Actually, when you package Angular, it deletes half of the framework code from the final build of your website because it doesn't need the compiler, it doesn't need all of the parsing mechanisms that are required to run the application. It just needs all this machine code to run it. Okay. And since this happens automatically, web workers are supported right off the bat because the animations will always be run on the UI thread, but then the data changing will always be run on the application thread. Okay, so the features that are available today when it comes to animations is styling. We can pass inline styles. Very soon we'll be able to have a CSS class that we can pass in that will animate itself. Basically what it will do is it'll pull in all the styles from that CSS class and animate that. We can animate styles or we can animate keyframes based on an offset, much like CSS keyframes. We can pass in the auto styling, just like with height star. You can pass in any CSS property and that will be automatically animated. We can also have different kinds of timing values, say milliseconds, or seconds as a number or a string, and pass in easing values as well. By default, when you animate something, it's animated in sequence, which means it animates one after the other, but we can have animations run in parallel using group. So in this example, we're animating the same element, but we're animating a rotation as well as a height change. But the rotation finishes faster before the height change. And finally, with the transitions, we can have different state changes. We could say go from any state to any state, or when it goes from state A to state B, and so on. Okay, so what about layouts? Because I did mention layouts, and I did mention that Angular is taking more strides to make layouts better in Angular 2. So if I were to design a website, build a website using CSS right from the beginning, I would want the CSS layouting tools to be automatic and flexible. And I could pass in configurations to get what I want. And we kind of take CSS for granted because a lot of the features in there, such as flexbox, display table, floats, all that stuff is automatic, and browser vendors have put a lot of work to make that stuff automatic. But CSS in general is fairly limited because it's a static language. Just like I mentioned with Flexbox, there are so many ways you can display something. And if you wanted to hook up transitions into the way that you're displaying things, it might not always work. Keyframes also could work, but keyframes are subject to having all the data in one spot when you animate it. So if you wanted to dynamically calculate the height, it would not be possible using CSS alone. So CSS and HTML, just like with CSS, both of these things are very static. HTML is great for describing data, but as soon as you want to have dynamic things, you'll need to use JavaScript. But JavaScript is a little tricky because you have to be a JavaScript expert to write your own layout mechanism. So if anyone's used CSS Masonry, that's a really cool tool for laying up pieces of a page together. That's using a mixture of CSS, JavaScript, and HTML. And for the average JavaScript developer, that'll be a little bit too difficult to put together. So with Angular, we have all this knowledge that we can figure out ahead of time with the CSS code, with the compilation code, to build a really cool layout system. And the nice thing is that if we have a layout mechanism in Angular 2, that will work with other platforms. So if you have a mobile device and you want to ensure that the layouts show up the same way on the mobile device as they do on a browser, Angular can do all the work that it needs to do to make that work. So here's the demo that I have. Basically what I did is I recreated Flexbox, as bad as that may sound. I've recreated Flexbox using the layout mechanics that Angular provides. So here we have 5 boxes. I click big to small. You can see that the boxes shift, small to big, and the other direction middle, where the middle boxes are bigger, and default sizing. If you were to use Flexbox for this, you'd realize that it's just a priority, right? You change the priority, the boxes will shift automatically. Transitions work sometimes, but not always. But this isn't using Flexbox at all. It's just using 5 boxes with display in line. If I look at the code for this, I have a layout component. In the layout component HTML, we have the buttons that I showed you that change the state. And they're just calling methods on the component. But then I have a list of numbers that I'm displaying on the page. So I have a repeated list of numbers. And then I have a layout animation, which is dependent on the priority of the number. If I look at the layout component to see how that works, we just have a layout animation that describes all 5 states. So there's 5 numbers. Each box could be a different size. And then we have a 0 state, which is the default size for each box. And we're describing the width. We're saying that the width is at 50% at priority 5. And then each of these methods is changing that priority. So you can see small to big will change the priority so that the first numbers are bigger than the smaller numbers. And middle will make sure that the middle numbers are bigger. There's actually 0 animation code here. The only thing that even triggers an animation is this transition that's saying that, okay, we know that you're changing state from big to small or small to big. Animate this for half a second. And by doing so, Angular is smart enough to know exactly when to run the animation and to run it for the Web Animations API, which makes it efficient. So this is the first stride that we're trying to take to making layouts a lot more flexible and adaptive in Angular 2. Okay, so with animations and layouts, what features are coming soon? Well, once I get back to work, I will be working on query, as well as other members of the team will be working on other features for animations. So query allows you to find elements within a component and animate those elements in parallel with the container element. So the nice thing about this is that it can work with sequence and groups, so you can make it serial one by one, or you can make it animate in parallel. So here we have another demo, which showcases a modal that when I click on the modal, you can see that it animates the container, the header, the body, and the content, just like that. Each of these elements were detected within the animation and animated with the DSL. The animation is a little long because there's so many different components in here, but you can see here we're using query to find the footer, the body, the header, and to produce an animation that has a starting value and an ending value and changes the transform properties. As the animation API gets more and more sophisticated, this code will get smaller and smaller because we'll have more features. So if anyone's familiar with the Angular router, the router allows you to route components together based on a URL. And we will be adding animation support to this so that we can have the router outlet, which is the container of the animations, have its own animation state, which could then detect the item that was entered into the page, the view that was put into the page, and the view that was removed. And once again, you can animate this in serial or parallel. And as the framework gets more and more sophisticated, you can actually pinpoint elements that will jump between pages automatically. And using the transition code, you can then specify which state happens and which animation is triggered. Okay, so a few more things before we finish. Styling CSS. We've used inline styles so far, but I mentioned that Angular has support for a CSS parser, and what this allows us to do is that we can actually take CSS classes and keyframes defined in our component CSS. So here we have a component that has an external.css file, and it contains this data. We can actually use the CSS classes and the keyframe, put them directly into our animation without having to have a bunch of inline styles. And this makes animations more portable because we don't need to have a copy of all the inline styles in our code. And if you think about something like Animate CSS, which is a CSS library for animations, that is all a bunch of keyframes. You can import the CSS file and use the keyframes directly in your animation code. So much like animations are portable using CSS, we'll also be able to make an animation module. So here we have a module that contains an animation called explode that does something. But this is a part of a module for the entire application, which means that in any component that's associated, we can use that animation directly, which allows for even more reusability. And the really cool thing is that when the animation's used, we can actually import it into the component and call it programmatically. And when we call it programmatically, we gain access to the player, which we can play, pause, or reverse, and set the position of the animation. So here's my final demo. Here I have a player that will animate the Angular logo across the screen. Once again, that's how it looks like. The animation is defined with our Angular DSL code, but I can actually gain access to the player and control it frame by frame. And once all the other features in the animation code, such as querying and the CSS parser are in the framework, we'll have access to multiple elements which we can control. And then later on, we'll be able to actually even pass in a gesture, so you can pass an acceleration to an animation and have a whole choreography of things happen. Okay, the last part is programmatic evaluations. You've noticed that the animation code, whether it is, despite the fact that it is dynamic, we are only passing in static data. So what about external data such as expressions? Well, using the expr method, we can have low-level calls which will do a calculation of data within the animation code. So if you think about something as simple as a click operation, when you click on something, you want to gain the X and Y values based on where you clicked, and you want to pass that into the animation. So something like this. I want to style it based on where I've clicked, and then I want to run the keyframe ripple animation. So those are two distinct things. We have the click stuff, and then we have CSS code. But the DSL allows those styles to communicate with each other and to produce an animation that's able to put dynamic data directly into an animation. So what does this look like? All that we would have to do once this feature is in is put a function on the window, in this case event xy, and we get the data that we passed in, and then we can return the x and y values to make the animation work. And the nice thing about this is that we'll have all this rich data that we can collect from the animation, such as all the styles that have been accumulated over time, as well as the style sheet that was parsed for the component, the event that triggered the animation, and any data that we passed in for the animation to work. And then to mix all that stuff together, you can take a CSS class, inline data, and dynamic data, mix it all together, and that will get passed into the Web Animations API, and it will animate it efficiently. And it will still allow for cool things such as scrubbing and callbacks to work. So a quick recap. We think about animations. We think about modern UI stuff. We really think about layouts and animations working together. We know that Angular2 does these animations. You've seen how it works now. We know that these layout features are slowly coming into the framework, and we know that there's more animations coming in. And we just reached 2.0, so there's still plenty of cool things coming down the road. Here are my contact details. Those are the slides once again. I'll keep those up for a bit. And remember to take a look at the GitHub repo. Looks like we have some time, so I can answer a few questions. So if anyone has any questions, please raise their hand. Yes, sir. Yeah. So the question was that in the beginning I mentioned that animations are limited to one element at a time with web animations. So the query mechanism that I had allows you to find an element, and then the parallel or the serial, the group effects allow you to animate them together. So you can collect all the elements you want, pass them into a group animation, and then have them animate in parallel. And since it's inside of that DSL code, if you gain access to the player, you can set the position, and all those elements will animate depending on the frame. That's coming soon, yes. Yes, sir.
Yes, so you mentioned that the new NGAnimate is not supported in many of the older version browsers. So what is the best way you would use to fall back onto CSS if the user's browser doesn't support it?
Right, so that's a good question. I forgot to mention that the Web Animations API is only supported in Chrome and Firefox, and soon Safari, not IE. That doesn't prevent you from using it. There is a polyfill that's maintained by Google that's made to be performant and efficient. If you just include it into your website as a script tag, they'll work automatically. And you don't need to rely on CSS. And it still uses CSS because it's a polyfill, but it's designed to handle these kinds of animations efficiently. Yeah. Next question? No more? Okay, thank you.